So if we look, $4, $6, $12, $20, basically 9. I'm going to count by twos. 4, 6, 8, 10, 12, 14, 16, 18, 20. And then going up, I'm going to do 50 cents, $1, $1.50, $2, $2.50, $3, $3.50, $4, $4.50, $5. Well, this is your X value, and this is your Y value in a table. And then we plot. So $4.75, so almost $5, and rounding's okay, is 50 cents. Almost $7 is 90 cents. And we're estimating, right? It's not going to be perfect. Almost $12.50 is $1.50. $20.50 is right at $3. And almost $9 is at $1. So I've plotted my scatter plot. The next part is to draw a line of best fit. So, like this maybe. Again, your line of best fit is going to be a good estimate. You're just not connecting all the dots. That's not the way that it works. Now, we did this yesterday when we did our line of best fit. We wrote our equation, which is y equals mx plus b. Plus b is easiest to identify. Where does this line of best fit intersect the y-axis? It's not at 0. Negative. Let's round, negative 50 cents. Right? I mean, we're rounding. It doesn't happen at 0 because 0 is right there. It's below 0. I'm going to zoom in so you can really see it. The next point, we're going to have to create 2 points to count our slope. Because if you look at my line of best fit, do any 2 points that are already on the graph fit on there already? Not necessarily. So I'm going to have to do a point to point. And if you look, I only want to put points at grid lines, where 2 grid lines intersect. So I could put a point here, but that's not on my line, right? I want to do that on my line, but only at intersections. So right here, if I look, if I estimate a little bit, that's about on a grid line. So I'm going to put a point there. Let's see, where's another grid line? Could I say right here? Is that a good estimate? And again, you're estimating. So it's not necessarily exactly on that grid line, but since it's on the line, I can put dots wherever I wanted. And the reason you do on those grid lines is because when they're on the grid lines, the intersection of those crosses, you can then count the slope. So let's count up how many. That's not 1. What is that? 50 cents, right? Up 50 cents. So how much did I go up now? $1. You're okay, just. So I went up 50 cents. I went up $1. I went up another 50 cents. So what's my rise? $1.50. So $1.50 over, let's count how many spaces I go over. If I go over one box, how many does that represent? 2. So another one represents 4, 6, 8, 10. So up $1.50 and over 10. Can you fill in the rest of the equation? Y equals $1.50 over 10 x minus 50 cents. Now, if we had not done this together, could your slope have been different than mine?
Yeah.
Yes. Could your intercept have been different than mine?
Yeah.
That's the problem with lines of best fit. Everybody's are a little bit different. It says if a diner orders a meal costing $10.50, how much should the waiter expect to receive? And then it says show all work. There are 2 ways to do these problems. The first way is to go on your graph to 10 and go up and estimate. What do you think that right there would be? 10 what?
$1.75.
Well, this line right here is $1.50 and it's a little bit below it. So maybe $1, I heard $1.35. If you want a better answer than an estimate, instead of x, you're going to substitute $10.50 into this problem. So $1.50 divided by 10 times $10.50 instead of x minus 50 cents. If you want a better answer than just estimating, $1.50 over 10 times $10.50 minus 50 cents, right? Instead of x, I just put in the value they give us. So mathematically, we'd estimate $1.08. It's an estimate, right? So everybody's answers are going to be a little bit different. You're doing the same thing. You're plotting, writing the equation, finding an expected answer. Remember, there are 2 ways to do it. You can visually look at it, or you can substitute.